Alright, so this is 8106. Chad is entering a rocket competition. And in A, Chad programs his rocket to launch straight up into the air with the function h equals negative 16t squared plus 92t, where h represents the height in feet and t represents the time in seconds. How long after the launch does it take the rocket to reach the ground? Okay, so I just want to kind of get a visual. I like to make a sketch just to get an idea of what's happening. So we've got the height along the side, and we've got time along. Actually, let me move that over, and we got height here. All right. So now we're starting, and then the rocket goes up into the air. It reaches some height, and then it comes back down. Okay, so this is 0, and then this is some time x, and then this height up here is the max height that the rocket reaches. The difference between these two, the starting time and the finish time, is the elapsed time that the rocket's been in the air. Alright, so let's answer some of these questions, starting with A. They want to know, what is the time? Well, we're looking at h equals negative 16t squared plus 92t. And I've checked, and we can't complete the square on this, so the only way to do this is the quadratic formula. And remember, we know that h is going to be 0, so we're going to get negative 16t squared plus 92t, and that is going to give us t for the starting and t at the finish. So then using the quadratic formula, we get t equals minus 92 plus or minus the square root of 92 squared plus or minus 4 times negative 16 times 0. Alright, so now all over 2 times negative 16. Alright, so then we know that this part here is going to cancel out because anything times 0 is 0. So then we're going to get t equals negative 92 plus or minus the square root of 92 squared is going to be 92, and then divided by negative 32. And so our math will be t equals negative 92 plus 92 divided by negative 32. So that's going to be 0 divided by negative 32, which is 0. And then t is going to equal negative 92 minus 92 divided by negative 32. And when you do the math on that, that's going to be 5.75 seconds. So we know, if we're starting at 0, we know that the rocket will be in air for 5.7 seconds. 5.75 seconds. Alrighty, so now coming back, they give us another question here. It says, write and solve an inequality that shows when, at what times, the rocket is at least 76 feet high. Okay, so now we're looking at when negative 16t squared plus 92t. Let me make sure I got that right. We're looking at when this is going to be greater than or equal to 75. Okay, now we need to solve this. So in order to solve it, we need to move 75 over, and we get negative 16t squared plus 92t minus 75 is greater than or equal to 0. So at this point now, we've got a quadratic and we want to solve our quadratic. So I'm just going to go to the quadratic formula. So we know that t is going to be minus 92 plus or minus the square root of 92 squared minus 4 times negative 16 times negative 75, all divided by 2 times negative 16. So then we're going to get t is going to be equal to negative 92 plus or minus, so what is that going to be? 92 squared minus 4, oopsie, not minus 4, times minus 4 times negative 16 and times negative 75. And this ends up being 3664 divided by negative 32. And so t equals negative 92 plus, what's the square root of 3664? And then we're going to get, I'm going to round 60.53 divided by negative 32. So I'm going to add negative 92, and then I'm going to divide by negative 32. And so I get t equals 0.98. Alright, and then I'm going to get t equals negative 92 plus or minus, or actually that's not going to be plus or minus, it's going to be, actually let me get this in the right place, t equals negative 92 minus 60.53. I'm going to say 531 divided by negative 32, and so t equals, what is that going to be? Negative 92 minus 60.531, and then divide the, oops, I accidentally, let's do that again, 92 minus 60.531 equals, and then divide by negative 32, and so you get 4.77 roughly, okay, seconds. Okay. So I rounded to the nearest hundredth. They're not really telling us, so you could keep it as an exact answer, and that would get you a little better results. I rounded to the nearest hundredth, so that might be, could make a little bit of error in there. So anyway, let's go back to the question. So in order to qualify, the rocket must be at least 76 feet off the ground for 4 seconds. And does Chad's rocket qualify? So then what we look at is what this is telling us. So when we look at the graph, we're going from, time is 98 seconds, we're coming up and down, and this is 4.77 and this is 0.98. So the time that it's in the air is going to be 4.77 minus 0.98. And so when you do that, see, the rocket will be in the air for what is that, 4.77 minus 0.98, looks like 3.79 seconds. So what did we have to reach? So in order to qualify, it needed to get off the ground for 4 seconds. So did the rocket qualify? No, did not qualify. Alright, and so the last one asks for, it says, what is an appropriate domain for the function in this situation? So we would say t is going to be less than or equal to 4.77, and t would be greater than or equal to 0.98.